All right, we are recording. Welcome everybody. This is the June 11th, 2020 Object Storage API KEP review. So I want to talk to something that came out of the Monday stand-up meeting, and I want to really take the temperature of the KEP, or the SIG rather, on where we should head with the controller architecture. And just to make sure that we're on the same page, or at least get us all on the same page before we move forward. So the Monday meeting, there was a proposition that rather than following the kind of bisected controller design with a central controller and then disparate sidecar controllers, that rather we go with a more library-like design that would be imported by provisioners and then used to operate on the APIs. And now Sid was the proponent in that. I'll let him take it from here. You can go ahead, Sid.
Hey, thanks, John. So far we've discussed the architecture for this cozy controller to have two disparate pieces. One would be the driver, which would be in charge of creating the bucket and managing things or reconciling the bucket state with the real world, talking to AWS S3 or Google Cloud. The other component of it would run alongside each of the application pods that require this bucket. And these two, we were talking about the current design proposal is having these two communicating with each other using gRPC. Now, I started implementing this controller, and as I started doing it, one of the things I noticed was in case of object storage, it makes sense to we can actually get away with just one controller rather than having two pieces that interact with each other. In case of CSI, let me start from there. In case of CSI, what happens is we end up with the need to mount and attach volumes to a specific host and to a specific pod in that host. In case of object storage, all of the data access or all of the volumes or all of the buckets are over the network, and nothing is local. There is no need for a local agent to do any setup related things for the pod for it to consume object storage buckets. So
can I ask?
Yeah, please.
What component is going to surface up the information about that bucket to the container?
So we've talked about so this controller would put in either environment variables, or some kind of config file, or set the service account for that pod to be able to access the object storage.
So if you talk about environment variables, that's on the node, right? So you need some component on the node to do that?
So the environment variable would be set while the pod is starting.
Right.
So you when you request a bucket, so we talked about having a field on the pod spec for a bucket. Until that actually happens, we also discussed the idea of having an admission controller, where say if a pod needs a bucket, they add an annotation, something like cozy.io/bucket name, some bucket. And what the admission controller would do is go and check if a corresponding bucket object by that bucket name exists. I'm just throwing around an idea here. And once say the bucket does exist, then the controller would go and update the pod object to have the environment variables that we want it to have, and then it'll go forward and get scheduled.
And what about if you want to surface it up as a file?
It's the same. It's not very different because again we're only adding fields to pods. In case of a file, we would be the controller would go and create a config map or a secret and mount it as a file at the appropriate location.
Presumably, I think the approach that you're proposing is you're mutating pods after creation, right? You're saying
Until we have a until we have a
sorry, go ahead. No, please.
Oh, I was just saying until we have an approach where you have buckets as a part of the pod spec.
So the problem with this approach is that your container is going to start potentially before your bucket is ready, right? There's nothing to hold off your pod from starting.
So that's the reason I'm using an admission controller for this. So if the bucket is not ready, it rejects the pod creation request.
I see. So you have an admission controller that monitors
annotations,
bucket objects, annotations, looks at the corresponding bucket object, prevents the creation of the pod object by rejecting it.
Yeah.
Okay, that's odd, but let's go with it. Because it could result in issues, right? If you have some programmatic way to create a pod and you get rejected because another object hasn't been created, that's just not the way Kubernetes works. You're supposed to be able to create all objects at the same time. But let's say this is for a prototype, okay? So you're saying you're going to create it, you're going to reject the bucket or reject the pod if the bucket's not ready. If the bucket is ready, is the admission controller going to update the pod, or is a separate controller going to update the pod?
So the admission controller is going to update the pod. So there'll be a separate controller that listens for bucket events and and if the user creates a bucket object, it goes and does the corresponding provisioning in the backend.
And why do you want to go with this approach? Because I guess my concern with this is like, it seems like you're enforcing kind of a order of creation on Kubernetes objects, which we generally try to avoid.
Right. I mean, that's the whole philosophy of it. So again, this is a stopgap measure simply because we don't have the appropriate things in the pod itself to prevent it from starting up until the bucket is provisioned. Ideally, like you said.
What's the benefit of this over, say, a like deterministic secret names or secret field names that a pod spec would block on
automatically? Yeah,
that's just a built-in feature.
Or I was even thinking a CSI driver that we discussed before.
Right.
Yeah, that would work too. Yes, any way to just prevent the pod from starting up is okay.
So guys, I have to say that while this is certainly a worthwhile conversation, this I don't think is at all related to the heart of the architectural issue. Right. What we're talking about is how to surface things to pods, but the issue was central controller plus sidecar plus driver versus bundling all three of those into the same thing. And the architecture never assumed that we had something running on every node, right? It was never. It was always an assumption that there would be one instance of a driver, one instance of a central controller, and one instance of a sidecar for each tuple. So I don't think that questions about whether or not you need anything on every node is relevant to the overall question.
It was never about every node. It was more about do we need a sidecar alongside every application?
So maybe I misunderstood on Monday then, because when we, or at least when I've been using the nomenclature of sidecar. When I say that, I mean that it's a sidecar running as a container next to a provisioner container within the same pod,
Yeah,
and they
not a
communicate with
sidecar.
each other over gRPC. Yeah, not sidecars attached to applications. Up until now, it's either been, we haven't explored the CSI solution yet, or that, or like just mounting a secret to the pod. So that, in fact, let me just to maybe give us something to talk to here. Have been working on many little diagrams. Let me inflate this. The general sense being that, so if you let me explain for a sec, the pod, or you'll have a pod in the our cozy controller namespace. This is our central controller. It's acting as a go-between for users that are requesting buckets and bucket access, and then the provisioners, which run in their own namespace. And the provisioner is composed of both a sidecar that we will provide that will ingest bucket and bucket access objects from the cluster scope, and then make calls over gRPC to a container in its pod, in the same pod, which will then actually execute against the cloud storage or the object storage interface. So does this still how you were thinking of it, or were you thinking of everything just being condensed into a library sort of model that provisioners would import and then implement an interface for, similar to like the old SIG store or SIG external what was it called, SIG lib library? Yeah, external lib library.
That's exactly how I was thinking of it. The second part where there would be a single provisioner that that would be provided as a bunch of stubs with underlying so any vendor who wants to provide an object storage controller would just have to implement the methods that are defined in the library and compile it to form a controller that would just that would go and call the appropriate methods as bucket requests come in and different operations are done.
Why do we want to go down that route?
Having a library here allows the vendors to control how they or control the pace at which they push out say critical security fixes to their own provisioners.
That would also be the case in the other model.
Right.
I would even argue that it may be easier because they're not dependent now on code on our side, and they wouldn't have to rebuild and re-release binaries or containers every time they make an update, or every time we have to make an update to the library.
Right.
They just get a new container.
There's also the other considerations too, like CRD management, right? When you put that in a central controller, then your lifecycle and versioning of CRDs is all handled centrally. Whereas if you make every single provisioner, that means every single one of them, you either have to install the CRDs completely independently via I don't know how, or every provisioner has to do their own, and then you have all the different version conflicts and everything.
Yeah, the nice thing about the current model that John has here is, when you have a separation of concerns, it allows different components to handle different things independently. So like the central controller that he has could be deployed by a Kubernetes distribution, for example, and ensure that logging happens such that no matter what cozy driver gets installed, it's going to be logged appropriately. Versus if you try to condense everything down into a single binary that a third party controls, it makes it much more difficult to do that. And like Andrew said, you may have one driver thinking it's going to use a specific version of a CRD, another driver that wants to use a different version of the CRD, and it just makes the system much more difficult to kind of work together.
Can you explain that a little more, please? I'm trying to understand this versioning issue.
So if
what,
you install CRDs as part of your installation of your provisioner, and then somebody else installs, and they install CRDs, then they probably have to not install their CRDs. But how do you know if you uninstall whether or not you should uninstall CRDs? Right?
So you're talking about the CRD for the controller itself.
Right.
Right.
I see.
For all of these new CRDs that we're looking at right here on the screen, right? Right. They're all
No,
part
I
of.
meant. Okay, so those CRDs. So you're saying there could be two different versions of the CRDs.
So the problem is if you make the CRDs a responsibility of the provisioner, provisioners are written to a particular version, etc. And then and so you've basically handed off a bunch of admin responsibilities to the individual provisioners, and then they can clash about their view of the world.
I see. Okay, so first, I think so. In the long run, we want pods to recognize buckets as a first class resource. If that's the case, then none of the provisioners would be defining what the bucket API looks like. That would be defined by us, like Kubernetes itself. And that's what we should be aiming for.
That definition? How do you decide when? Because the CRDs are not going to be part of core Kubernetes, right? They're going to be some add-on here. So
Right.
how do you get them installed then?
If you're going to get into the pod spec, it's going to be a core part of Kubernetes.
Right, but there's no more core API objects, right? Even if we're talking about something being part of the core, they're recommending that they be CRDs.
Understood, but what I'm saying is when you create a new API object, if you even if it's a CRD, if you define this object during the cluster creation time, it's not something that individual provisioners decide the definitions for. It's something that's defined by the cluster.
Right.
Maybe it's feature gated.
But this is not how we typically install it. We always install it after, like the controllers are installed later on with the cluster. So it might be related to the cluster, but not in a centralized location necessarily.
Right, I understand. So again, when we want to make this a core part of or a first class resource in Kubernetes,
It still
I think
needs
it's okay
an
to,
owner. Still
sorry?
needs somebody to own a CRD. A CRD needs an owner to manage it and lifecycle, and upgrade it and do whatever is needed. And some entity
So
being deployed needs to be able to.
I think what
tied to
Sid is
that.
saying is like, even if that's the case, why can't the owner just be Kubernetes or some component in the distributor? And you know, it can be that's true. The details of how that's actually going to work has not been figured out. Honestly, we've gone back and forth with SIG architecture to try and figure out, you know, how are CRDs that core components depend on going to be installed. And this was a challenge we ran into with CSI, and at the time there was no good answer. So the CSI components ended up being core API objects. I don't know if they have a better answer now or not, but it's probably going to be a challenge that we're going to run into regardless of which one of these two approaches we go with. But that said, I think we need a kind of a stronger justification to go with a library model, and I'm not hearing that yet.
if we went the gRPC route, we would make it even harder for ourselves to, or let me explain this way. So if we do go the gRPC route, one, we would be taking up, going from the gRPC way of doing things with two different components to actually making pod a first class resource. I'm trying to just imagine what that process will look like, because whatever is in that.
So when you say the gRPC approach, though, where's that interface lie? What are we talking about communicating over gRPC here?
Right. So the existing proposal, we have a driver that is vendor specific, and we have a sidecar to it, which knows how to talk with Kubernetes. And these two components talk to each other using gRPC. I've just used the term gRPC to describe it.
Okay.
Yeah.
But that has nothing to do with the pods, right? That I guess that's my point.
So
That is completely an artifact of interacting, of providing a clear boundary to the provisioner so that it can sit behind an interface that's independent of Kubernetes, independent of Go, independent of all of that.
okay, yeah. So I think there are two things we're talking about. One is, yes, how the credentials are going to be passed through into pods. The other is, what's the interface between the vendor's specific provisioner part and the Kubernetes side of things. For the second question, I've been talking about providing a library, and the existing proposal was to have a REST interface. Essentially, they're going to serve the same purpose. And if maybe I got it wrong earlier, but if you're telling me the interface is going to be a single sidecar that acts, it's really nothing different from a library. A single sidecar that would be deployed alongside the vendor specific controller. That actually, yeah, it's not that much of a. I don't see technical merit going from that to just a library.
Why do you have to have a sidecar at all? I mean, this is a technical detail of the provision, or
right.
Doesn't have to be this way. If the provisioner wants to to watch bucket, the cluster bucket entities, bucket access, and reconcile them to its object storage without a sidecar, just having a single driver watching like a controller. That's a controller.
So the reason is the reason we do that is because the sidecar will define what the CRD itself is.
But do you have the cozy controller here to represent these CRDs and manage their lifecycle? Why do you need the sidecar to define anything?
Yeah, actually, let me add to that.
Yeah.
I suggest the sidecar idea because it kind of separates the Kubernetes interfaces from the driver interface. One of the really nice things about the sidecars from CSI is that it allows the driver developer to only concentrate on the gRPC interface, and that alone at a certain version. Now the Kubernetes versions change quite rapidly, and the sidecar actually manages that bridge.
But
so,
is this still the situation today with controllers? Are you still worried about writing a controller as an object storage provider?
well, I'm just trying to define that a sidecar provides a level of encapsulation and
but it's an internal encapsulation. If a provider wants to encapsulate something, let it encapsulate whatever it wants to. But what
of course,
the purpose of the standard?
I agree. But what I'm trying to say is that it is normally very difficult, after working with CSI for so long, that newcomers writing drivers for these interfaces find it actually quite difficult to ramp up. But by the community providing the sidecar element at a certain version that's already tested, all they have to do is ingest that one CSI driver or that one implementation in the backend for the sidecar, and that allows. Does that make sense?
Yeah. So when the newcomer to Kubernetes ends up writing a library, you're saying they would follow. They would essentially take a library that does and then fill out some methods. Like in case of CSI, you filled out attach, detach, mount, and unmount. And the library would take care of doing the gRPC calls to the actual to kubelet, right?
Yeah, I want to separate the word library. I'm not talking about the actual implementation. I'm just saying that there's something that abstracts the API of Kubernetes and its control, and there's something else that abstracts the interface to the driver. That way,
yeah, I don't think
yeah.
we need the gRPC interface at all. It's just the controller. We just have the experience for the developer would still be the same.
Yeah, I would encourage using gRPC because it breaks away the necessity of creating libraries at different languages. The controller can be written in one language, and the driver for that can be written in any language. We got CSI drivers written in Python, most likely C++, and
Yeah.
Golang. So you don't want to
Why not leave it to the providers? If a provider wants to write in Python, what do you care about
Guy,
how it's accessing API?
If I may,
Yeah.
you're absolutely right. I think you're both in violent agreement here, even though it sounds like you're not. We have to separate the spec from the components that we offer the Kubernetes community, right? The spec itself does not care how the driver is packaged. It does not care whether there is a sidecar or not. You're absolutely right about that. And the spec would and should never dictate that. That said, what does the Kubernetes community offer to developers to make their life easier, right?
But do you think there is a case for making life easier for writing a controller that reconciles a bucket to an object storage? Is that really something you feel like there's a gap?
So there's two components that we're encouraging here. One is the sidecar and one is a central controller. The arguments for having a sidecar is exactly what Luis was arguing, which is it kind of decouples the logic for interacting with the Kubernetes API into a standalone binary. And so we, the Kubernetes community who are experts in interacting with the Kubernetes control plane, can provide a standalone binary for vendors to use. And as a vendor of a cozy driver, you can go write the driver in whatever language you want, write it once, as long as it's compatible to the spec. You just need to ensure that it is paired with a correct version of the sidecar. So as a driver author, your life has been made easier by using a sidecar versus an integrated library.
I don't think it's that simple, because now if you just had it as an integrated library, you get the benefits of the type system from Go itself.
Right. Every time Kubernetes is updated, now you need to go and update your driver. And that library now needs to come in all the different language flavors that vendor authors might want. Instead of us writing one Golang sidecar and compiling it and giving people a container where they don't care what language it's written in. If we write a library, we're going to need to provide one in every language.
So I don't think that's required, actually, because when we did this for the cloud providers, we only gave it in Go.
Yes, and that was
and it worked very well.
of that approach.
Sorry?
And that is one of the reasons that we're kind of moving away from having cloud provider code in core Kubernetes and having extensibility layers wherever we can.
No,
but Sad, I think there's a missing point here. Providers always.
So Sad, I was the one who proposed the breaking up our cloud providers, and I'm saying after we did that, what we provided was a Go library that individual cloud providers could implement themselves. The vendors could do themselves, and they built their own controllers. And all we did was maintain the Go library.
Right, but that's strictly more difficult and less flexible for driver vendors, right?
But is
You're
there
telling
really
them that they must
anyone
use Golang? Sorry, go ahead.
Is there any provider that you know, because I know none yet, for using OBC that was not already a controller for other reasons, right? For deployment, for configuration, for whatever CRDs are shipped with that provisioner, right? And
I mean, all the CSI drivers that we know, they don't ship controllers. They ship a driver that implements a gRPC interface, and then that's it. And there's
case of
more than 50
CSI,
plus
it makes,
CSI drivers.
in case of
And-
CSI, it
Okay.
makes more sense because you can have backends that are specific. So say the Photon backends written in C, C++, and in those cases you want to write your driver in C and C++. Your client libraries for your own platform are probably in different languages. But here we are only doing REST.
I do, again, I'm discouraging from that point of view. We got, it's just it's not about embedding your server side into some code that you already had in some control plane. We're just trying to make it, as a community, able to use any language. So for example, in CSI, we got Ember, which is written in Python, as a model, and then that communicates with Cinder, and then communicates with something else over REST. So we don't know what the backend is. But I think what I'm just trying to encourage is the ability of allowing the community members and driver developers to choose their own language as long as they have a network interface, in gRPC being one model.
I think that's an important point too, because we don't want to lock out vendors that just don't have a Go client.
We
Just
wouldn't
for-
really be
just for the
locking
fact
out,
that-
but the effort to ramp up would be higher. Anyone can write a controller. You're just talking, the REST API to Kubernetes.
Well, right, but then they'd also have to write a Go client for their object store interface, right? And that's not a small amount of money. I mean, that's a huge technical debt, and you have to expect
Agreed.
it. Yeah.
Yeah, the effort is much higher. Actually, now that I'm a little bit clearer on what this distinction is, or where we're trying to, break apart things, I think it, technically speaking, it doesn't matter if it's over gRPC or if it's a library. And so far, like Saad and everyone else is saying, I think gRPC makes sense because it doesn't add too many disadvantages as compared to library approach, and it does add the flexibility options. So, I mean, to me, it makes sense to have the existing approach there.
Is a serverless model applicable here as well, for instead of like gRPC and making up like choosing a different, like a default protocol, because provisioning is typically not, so it's not a data path, it's still control plane, and if the provisioner would be an image to be run like once, like a like a call, that would sort of eliminate the need to well, it will require some other adjustments from the controller in order to submit this as a pod, I guess, and monitor that. But other than that, it would
I mean, it would be a local binary that's running. Yeah.
No, so
It
container
doesn't-
would probably be the local binary version of it, but so that would.
I think
be a
like
service
the
model.
way that we should design this is make it as extensible as possible and let the vendors choose. So the way that it's designed today is on the Kubernetes side, we provide a sidecar container. But if there are vendors that don't want to do that for some reason, they completely have the option to go a different route. So we can do the same here. Let's give maximum number of options. Let's not be super, opinionated here and say you have to use Golang, you have to import a library. That's the only way.
Or even gRPC.
Right. So say, hey, all you have to do is implement a gRPC interface. If you want to do that, great, here's the sidecar. If not, you are welcome to do whatever you want, because per the spec, it's all legal.
Yeah.
Yeah, I agree with that.
Yeah, I don't think it's asking too much to ask people to learn a little bit about gRPC. It's a well-documented system.
Yeah, and it's got a lot of advantages to it. It's probably easier to work with REST, so people might start working on it quicker if it was REST.
Yeah, true.
Actually, there is just to add, there is a REST gateway for gRPC. So
Yeah.
But
There you go. Okay.
the really nice thing about gRPC is that there is a contract. There is a
Yeah.
contract, and you know exactly what you're supposed to get at whatever version you're using. The thing about REST, which REST is great, but you don't have a contract, right? So you have to bring the contract some other way. Yeah, I mean, I'm just talking about Thrift, gRPC. Any of those models have a contract, and that's really beneficial.
Actually, when you put it that way, I think it makes sense to enforce gRPC even.
Yeah.
It's not really
Because
different than the CRD API, though. I mean, both
exactly,
have
yeah,
a schema. It's not really a contract. The contract will be a documentation, but it will
Right.
be just a schema for what you get and what you can return, right?
Right.
Mhm.
Still
But
break the contract.
again, if we separate the schema of Kubernetes and the schema for the implementation of a driver, that's the model the CSI uses, right? And I encourage, if you haven't tried it yet, I put it on the chat, but I really encourage you guys, if you haven't done it yet, to write a CSI driver in whatever language you want and just insert it and have it just log and just do nothing. But I think that experience will let you know how to write a driver for different versions of Kubernetes. And when you get that experience, I think it may help here.
Yeah, yeah, I've done that. So coming back to this, talking about maximum flexibility that's how it's mentioned. Rather than having them communicate with each other, these two components, since they're anyways going to be over the network, why not use Kubernetes APIs itself for it?
For but
So
between which two entities?
sorry, what?
Between which two entities here?
So the two entities would be oh, I see. The part that knows how to talk to Kubernetes and the vendor specific part.
Yeah, and so the intent here is that, the bucket access and the bucket API objects are the communication pathway between the cozy controller and the provisioner's sidecar. So that will be the method by which they talk. They won't be communicating over the network at all.
So you're saying they don't talk to each other directly?
Correct. So yeah, it's not depicted here, but the flow would look something like: I, as a user, create my bucket request. I reference a bucket class. The cozy controller detects the bucket request, creates the bucket cluster scoped API object. Asynchronously, the sidecar and the provisioner detects the new bucket API object, which will contain all the information from the bucket class and relative information from the bucket request, communicate to the driver over gRPC, passing that information along to dictate how the provisioning is done. The driver, of course, reaches out to the cloud provider or the object store, creates the bucket. The provisioner sidecar writes back to the bucket cluster scoped object relative connection data. Now, this is broken up between, on the right-hand side, storage management, and then on the left-hand side, user and access management. So I'm just speaking to the storage right now. But then the controller would detect the update in the bucket. The cozy controller would detect the update in the bucket, and then update the bucket request to indicate that it is now ready to be used. And then in this diagram, but it's until we figure out how to integrate this with CSI, the cozy controller would write the endpoint to a Kubernetes primitive. Here it's the access secret, which would also in this case contain connection credential information, but that we can, if we just ignore that for a moment, that's how that data gets back to the pod. So you have this sort of asynchronous messaging through the API objects, the bucket access and the bucket.
So I just want to run us through this one thought exercise. What if I think it's worth talking about. What if we had the driver and the sidecar communicate with each other using CRDs rather than directly?
I think that kind of defeats the purpose of the sidecar at that point.
Yeah.
If the driver has to be Kubernetes aware, then it may as well just watch buckets and bucket access objects.
It has to be Kubernetes aware. It's a cozy driver for Kubernetes.
The binary that the storage vendor writes does not need to be Kubernetes aware in the model that is proposed here with sidecars. That's kind of the whole purpose. I think a lot of us take it for granted that writing a Kubernetes controller is easy. For people who are not well versed in the Kubernetes ecosystem, it's a pretty daunting challenge. And
Fair
so
enough.
if we can minimize that by saying, hey, don't worry about any of this Kubernetes stuff, just write a gRPC interface, which is well documented. I think it's well understood how to do that. And then pair it with a sidecar. That's just, it lowers the bar.
And containerize your driver, and then that's pretty much it.
Yep.
Yeah.
The only requirement then is that they'd have to run in the same pod, so they could, at least in the model I've got right now, they can communicate over the pod network. And that's about the
And that solves all kinds of security issues. So then you don't have to worry about any of the access or anything, right? You can just write in a local Unix domain socket.
Yeah,
Right.
that, yeah.
Deal with HTTP permissioning and all that.
Uh-huh.
Oh yeah. No, HTTPS would still be needed because you could snoop in if you're on the node and just look at all the network traffic that's going through an interface.
It's not network. You write through a Unix domain socket. You mediate through the file system.
Yeah, the security benefits of gRPC over Unix sockets are huge.
Perfect.
Safe.
Yeah.
Oh, that's good to know. Okay.
But essentially, the API that the gRPC protocol will define would probably replicate, if not match, in some ways to the bucket API in CRDs, right? Because it probably won't make like a complete translation between reconciling a bucket and the API to the provisioner.
Becomes an imperative version of the API.
I mean, it's very much akin to the CSI interface. So you have a small number of imperative calls with well understood semantics compared to the whole state checking and reconciliation approach of Kubernetes.
Right. But the state, in essence, of what we are actually doing would essentially be structured pretty much the same, right? If I'm creating a bucket, I would receive probably most of the things in the bucket API CRD.
Yeah.
Maybe for deletions it's different, but still, yeah.
Yeah, that makes sense.
Before we kind of bring the gavel down and decide for this model, I just want to poll the room and see if anyone hasn't spoken up yet that would like to give some input before we move forward and kind of completely commit to this. Is there anyone out there that would like to have something to say about it?
I agree with Saad.
That's a safe safe bet. Going once, going twice. Okay, all right. So I just from moving
There's one
forward.
more thing.
Oh, go ahead.
So there's one more thing that we didn't actually finish talking about, which is, so yeah, the interface can be gRPC. The second thing is, how is this information passed into pods? Can we talk about that?
That is something we've been, or maybe I've been kicking the can a little bit about, and we need to explore, or perhaps I need to explore how we can integrate this with CSI. Saad's mentioned it a few times. I think it's a great idea. I just don't know how it works. And so it's something I'm going to have to look at. So in the meantime, I've been saying that we'll be using Kubernetes primitives like secrets that a pod would have to mount and thus would have to know the name of. So
It would be the same with this volume too, with the CSI generic projection. I think. What was that, Saad?
Sorry, I was zoned out. What was the question?
The question is, you mentioned a certain volume type in CSI that could be utilized to hold the pod from being scheduled.
Yeah, no, the proposal there was basically write so for a prototype that we're talking about, we want to be able to hold off the pod from starting. One mechanism to do that is to use a volume. And CSI allows you to write an arbitrary volume extension. So you can imagine writing a CSI driver that acts as an adapter to a cozy driver.
I see.
So this adapter basically would allow you to pass a set of parameters that are specific to cozy, And in your pod definition, you say, I want this special cozy adapter CSI driver, and here are the parameters to pass to it. And so when it starts, the existing Kubernetes mechanism already knows, oh, it's a CSI driver. I don't know anything about cozy, but since it's a CSI driver, I'm going to hold off on starting this pod. And then the adapter can figure out what it needs to do in order to interact with the different cozy components. But that would just be kind of a stopgap solution until we have something more robust.
In the kubelet itself, right?
Right.
Yeah, I like this approach. And the worst case, if SIG architecture things take longer and longer, the CSI would still continue to function.
Exactly.
So here's the amount of code that I've got right now. So I've got a control. I've defined all the types, and I've got a controller. I've got an admission controller and a bucket types controller. The admission controller would look for pod annotations, like I said earlier. I think I can take away the admission controller piece, and I can just document something saying a pod needs to be started with this CSI driver or this CSI spec asking for a bucket. That would be the user's responsibility, right? In how we've been talking about it so far.
Right, in terms of specifying the CSI volume to use.
Yeah. If someone wants a bucket, the user would say, okay. So if that's the case, yeah, if we have a meeting on Monday, right?
Yes.
I can probably show like a quick demo of the CSI volume plus the bucket controller. It wouldn't be a full-fledged one, but it would probably just be something as simple as a pod requests a bucket. Then the provisioner goes and provisions a bucket in the back end, and then it gets mounted into the pod, and then the pod starts, something like that, without any of the fancy credentials bits.
Okay, cool.
Yeah,
that sounds good.
Yeah. Does that sound good? Sorry? I could use help from others if anyone's interested in helping me write this. If someone wants to take up the CSI part or the driver sidecar part, you're welcome.
Yeah, so I think this is important now. Like, this is not a project that should be put on one person's shoulder. Right. It's going to be insane. What I recommend is we are approaching the end of the quarter right now, and we're probably going to be doing a SIG storage planning session in the next, like around the end of the month. And what we can do, if you guys can kind of break down the different pieces that need to be worked on, we can try to recruit people in that SIG storage planning meeting to see if we can get folks to work on it. But what that means is before then, we should have kind of a standalone tasks that folks can be assigned to. That'll make it easier to kind of recruit people. If you can say, hey, here's a standalone task. If you want to help, jump in, and then they can start participating in the stand-up as well.
I think that's a great idea. When is
and it sounds like.
Sorry,
what? Yeah, just wanted to say it sounds like.
Sorry. Go ahead.
Please go ahead. Okay, John. I mean, so it sounds like Monday it might be too much to plan some demo. So I would maybe make some progress, and as it's ready, we can actually do some demo, right? Because I don't want you to take this responsibility to have it by Monday, because I don't think.
Oh no, I've already gotten a whole bunch of things in. So I'm working on this full time. So ideally, what I just want to do is, obviously I can't do the whole thing, but if we can go ahead and define an early version of, or rather than early version, just the boilerplate for the various interacting components, then we can have individuals contributing to different parts of each of them. separately.
Yeah, I think the
And let-
blocking piece is probably getting the spec defined. So if we
Right.
could get a repo created for that and someone starts kind of putting together like a 0.1 of the spec, that would be a good starting point.
I've
That-
got
that's
a
right.
private. I've got a repo in my own repository doing that. But how do we get one that's a little more official, maybe?
So, I think we finally got hammered out with Kubernetes org. And Saad, my suggestion on the issue is that we create a cozy topic under kube org. Does that sound good to
Yep,
you?
that sounds perfect. And maybe prefix the name with cozy. That way they're all easy to find as well.
Yeah, definitely.
Cool.
And Sid, so do you want to shoot for Thursday instead of Monday to do like
Sure.
a demo, as that's the broader group, and the Monday meetings are more of just kind of a stand up, like here's what I've got thus far, and we can
I
use
see.
Monday to hammer out the separate components that we could ask people to work on. How's that
Okay.
sound?
Definitely.
Yeah.
Yeah. No problems. That sounds good.
I'm
Yeah,
also
I'm
curious
working on
about
this
CSI part
full-time,
you
so-
mentioned. What did you
Sorry?
mean by CSI? You mentioned like CSI part in your like plan
Right.
for the demo. The CSI part means what? I'm sorry.
So we just talked about a topology where a user would request for a pod, and when they need a part of the bucket, and the way they request for a bucket is by defining a CSI volume with a particular CSI extension.
Got it. Okay, understand. Thank you.
Okay, cool. Then hey, so we're coming to the top of the hour here. Sid, I'll go ahead and create a Google sheet that we can start filling out ahead of Monday.
Okay.
And then we can just kind of go over then.
Okay.
Beyond that, I don't want to take up any more of anyone's time, and want to thank everyone for coming. And we hold Monday meetings as a stand-up for anyone who's actively working on cozy documentation or code or anything, for those interested. And beyond that, I will see you all on Thursday. Thank you.
See ya.
Take it.
Thanks everyone. Take care.
Bye.
Bye.